Very good afternoon, all the participants. And our speaker, ma'am Gitanjali.
Good afternoon.
Afternoon. Ma'am, you are a presenter. Can you share your slide?
Yes, sir.
Checking. Yes, ma'am, it is visible. Okay.
Okay, sir.
Now I request my colleague Alauddin Ansari sir to introduce our speaker. Alauddin sir, please.
Good afternoon to all participants. Thank you, Dr. Ramkumar sir. It's my honor and pleasure to introduce Dr. Gitanjali R. Sindhe ma'am. She is presently working as an assistant professor in Department of Computer Engineering in Vishwakarma Institute of Information Technology, Pune. She has overall 13 years of experience in teaching as well as in research. She has done PhD in wireless communication from CMI, Aalborg University, Denmark in May 2018. She has obtained ME and BE degree in computer engineering from the University of Pune. She has received research funding for the project Lightweight Group Authentication for IoT by SPPU Pune. She has presented a research article in World Wireless Research Forum, that is WWRF meeting in China. She has published 50 plus papers in national, international conferences and journals. She has authored 10 plus books with publishers like Springer and CRC Taylor and Francis Group. Also, she is editor of many books. Her book, Data Analytic for Pandemic, a COVID-19 case study, is awarded as an outstanding book of year 2020. Thank you, ma'am. Over to you, ma'am. Please start the session.
Good afternoon to everyone. Thank you, Ansari sir, for nice introduction about me. I would like to thank KEC Engineering College and Dr. Ram sir for inviting me, giving me opportunity to discuss this topic, that is machine learning, with all the participants. So good afternoon once again. Am I audible?
Yes, ma'am, you are audible.
Okay. Is slides are visible?
Yes, ma'am. Let's
Okay, so the topic of today's discussion is machine learning overview and the hands-on on machine learning algorithms. So before directly starting with or diving into the today's topic, that is machine learning and overview about the algorithms of machine learning, I would like to start with the why actually we are going towards machine learning. Like in last 10-15 years, we are hearing this word machine learning, artificial intelligence. Then why we are going towards that? So before directly going into machine learning, I would like to discuss the artificial intelligence. Nowadays, you have seen lot many examples where the artificial intelligence has been used. But why actually we require that? Like as a human, we are blessed with the natural intelligence. Like suppose this has been the COVID is not there, then it might possible that there are lot many conferences or this conference or this FDPs also would have been offline. So at that time, whenever the any like a human being, when they reach at some unknown position, unknown situation or unknown environment, at that time, as a human, we are very good to good into finding out the patterns. So we find out the pattern or the which type of people we will be comfortable with, and then we will definitely go in and mix into that group of people, and we start interacting with them. Within the first 20 or 15 minutes, we could find out the pattern. The same thing actually we are trying to do in the machine learning and artificial intelligence. The very first thing is that finding out the pattern. Here, as I have given example, we find out pattern in the humans or whatever maybe data is there. In artificial intelligence, we are trying to find out the pattern in whatever maybe data over there. The second point is that whatever may be the situation on whatever may be the values we are having at that position, a human are very good to take a decisions. Like take an example, if you are driving a car, at that time suddenly some object is coming there, at that time you don't need to tell someone else that now you need to apply a brake. in that situation, what needed to be done, humans are doing that. So that thing is that we are the blessed with natural intelligence. Then why we are going for the word artificial intelligence? The reason is that a lot many things that is not possible to pre-program. Like as we are computer engineers, we are very much good in developing lot many applications which have used widely and which have the removed lot many complex work of human, and it made human life very much comfortable. So this is the very first thing. Second is that in lot many applications, locations where human is not it is not feasible for human to go there, so human limitations are there. And the second thing is that everything is cannot be pre-programmed. Like I had given example of the driving car. So nowadays I hope you everyone has heard the Tesla is promoting the they are driverless car. So in driverless car, is it like that we can write a big program for each and every situation that could come, and that program can be written? So definitely this is not possible, that we cannot write the each and every situation that could occur in future and how to behave that car, how it will behave, because the road conditions are different, then which type of obstacle will be there, at which location it will be there, then what will be the size of that obstacle in front of the car. So we cannot pre-program these things. So these are the few reasons that definitely we would like to have a machine which can mimic like a human brains. So that is where we come up to the artificial intelligence. And now if there is I had given example on slide, that is the household work. Like if I would like to implement one robot which could help me to do housework or to just arrange my wardrobe, then definitely it shouldn't be a pre-program, because it will require a big program. Because at my wardrobe I keep lot many different things, and every time whenever I will purchase new thing, it will be definitely different. So every time I'm not gonna pre-program for that. So that is the reason there we required such a type of machine. It could take decisions based on the data. So at this point we required the part of machine learning over there. So these are the few examples of the AI that is I had already explained, that is self-driving car. And you might have observed the chatbots. Nowadays, whenever you are surfing on websites, at that time there are the chatbots. They ask you, may I help you? So these are nothing but the examples of our AI. So now next examples, I think about to implement the AI, we require the machine learning algorithms. So for data science, a lot many examples around us, like I hope everyone is aware about the Netflix, how they are working about. So they are looking about the custom clients, the users which are watching the Netflix programs, at which point they are forwarding which different type of programs they are liking. Based on that, their recommendation advertising has been done, and they have got the lot much growth in their business because of using data analytics, data science, and these are nothing but based on your machine learning algorithms. So what from this discussion, what we can say that why only in this 10 to 5 years this machine learning is very much boom? Because the very much important point is that the huge amount of data is available around us. Like in old saying was the time is money, but nowadays it has been changed. Data is money. So this data is generated because of the technologies like IoT, Internet of Things is there. A lot many devices are on internet. So huge amount of data has been generated. And why not from this generated data, why not to improve our business? And second point is that why not make our human life comfortable? And if we can save human valuable life, then that is the better thing that any human can do. So these things can be done using machine learning. So if you are going to see the definition of machine learning, there are lot many definitions. On slide, I have kept few definitions by the, I hope everyone here will definitely know the persons whichever they kept name on my slide. So these people are having very much good books on the machine learning. So each and every definition, whichever you are going to look for machine learning, two important points are there: data and past experience. So we are trying to implement such a machine. Machine means definitely one of the software program that we would like to implement that will learn from data and past experience, and it could able to predict the future. That we are trying to do. So that is nothing but the machine learning. So what are the different applications that we can discuss about machine learning? So here on slide, I'm just trying to give you the big picture of the broad picture of machine learning, means in which different domains machine learning can be used. Can anyone just tell me a few examples or domains where machine learning can be used? Or you can just unmute yourself and you can discuss with me what are the different applications or domains where machine learning can be used. Yes, this is prediction, weather prediction. Yes. So disease prediction, healthcare is the biggest domain where this machine learning application uh, have been started using, because to detect disease at early stage is very important. Then and then it is possible to save valuable human life. So to detect the diseases, yes, online shopping. Yeah, in online shopping also we are using machine learning. Uh, so we will discuss about very first the healthcare. So in healthcare, it is very much important to predict or detect the disease at early stage. Like there are diseases like the cancer, if it is detected at the early stage, then it is possible to recover from that disease, or we can save the human life. So for that reason, the machine learning algorithms are used in this field. Then the second is nothing but it is not only for the computer engineering field. It is widely used in mechanical engineering also. Like lot many mechanical firms, they are not only mechanical, lot many firms they are moving towards the machine learning instead of traditional working. As an example, we can take in mechanical engineering firms. Definitely there will be machines, and that firms would like to know from after how many years that machine will have the fault. So the prediction of mechanical failure in the machineries, that is going to be done using machine learning, and for that the some precautionary measures can be taken, and by that way the life of machines can be improved. Then in civil engineering also, the structural damage can be predicted, detected using the machine learning. In farming, the type, depending on the type of soil, the which type of crop can be taken there, and how production can be improved, that can be done using this machine learning application. So this is the wide area or domains where we can use the applications of ML. So yeah, Renika ma'am has said in food industry to check the freshness of fruits, vegetables. Exactly. So lot many applications are there. We can use the machine learning. So here now we will, till now we have discussed about why there is need of artificial intelligence. If there is artificial intelligence, then why we are actually going towards machine learning. Now we will discuss about how exactly this machine learning is going to work. So machine learning algorithms are uh, worked based on your data, the which type of data you are having. Like uh, if you are in your data, if you are having the labels, means some supervision is there, like based on this feature of this feature I would like to predict. So at that time you are going for supervised learning. Unsupervised learning, it name itself is explaining that there is no supervision, there is no supervisor to tell what exactly needed to be done. Like in supervised learning, there is the labels of your data set that is going to tell you that what exactly you want from that data set. And these are the three types of machine learning. So here we will first discuss about supervised learning. Like on slide I had given a few images, and each and every image is labeled with one label. Like first is red apple, it is label is apple, and then second image is also apple, third and fourth images are the yellow banana and the another is a green one. So 4 images, each image is having label with it. Meaning is that whenever your machine learning algorithm is going to learn from these images, then what it is learning? If such a type of shape is there, then you can call this as an apple. If such a type of shape is there, then you can call this as a banana. So whenever new image you are giving, suppose the image of banana with black dots you are giving, then definitely this algorithm will say that, yeah, this is a banana. So this is nothing but the supervised learning. That is for supervision is provided using the labels of your data. Now we will see here is the unsupervised learning. The unsupervised learning means data is there, but for that data labels are not present. So this your learning algorithm should understand some characteristics and should able to give labeling to it. Like it should able to cluster this data. Like suppose this is first is apple, second and the right and last. These are nothing but from the one category. These 2 banana are from the another category. So in supervised learning, the labels are not provided. So here we are going to discuss more about the supervised learning over here. So in supervised learning, if you are going to, now here, why exactly we are trying to learn this algorithm? Very first is that we are having data, and from that data you would like to predict something, or you would like to categorize something. Means whatever may be data from that, take an example, you are having data of customers who are visiting to the XYZ malls, one of the mall they are visiting. So from that, what knowledge that owner of mall will have to take. So which knowledge he will interested in? He will interested in the type of customers, like which customers are taking buying the products in which month of the year, or he could want to know that in 12 months in which month there is the less sale of their products, then what can be the probable reasons. And if I want to recommend advertise, then which type of people I should advertise the if there is any sale is discounts are there, so which type of people I should advertise the new arrival clothes. So depending on the pattern in that data, depending on the pattern people are doing the shopping, based on that definitely he would like to categorize the people. So that definitely can be done using machine learning. So here in supervised learning, we are having 2 main types, that is the classification and regression. By that way, we can predict or we can classify data. And the second, in unsupervised learning, we are having clustering and association. So further, if you are going to if you are going to check which algorithms are there with supervised machine learning, then for classification there are the algorithms like logistic regression, SVM, support vector machines, decision trees, random forest, and many more, but I have enlisted only few here. In regression, we are having simple linear regression, multiple regression, and polynomial regression. And same goes with unsupervised learning. I have listed only k-means and neural networks. So there are lot many flavors of k-means. So here now we will discuss about supervised machine learning. The very first question that should be in a mind, that whether I should go with classification or regression. Now we are clear with that when I should go with supervised learning. Whenever there is the label with my data set, a label means take an example of the salary. I would like to implement an algorithm that can predict the salary if I will provide that algorithm the experience of person and the post of person. Based on that, it should predict a salary. So here your salary is nothing but the label, your outcome. So if in your whenever in your data set you are having the label, means label data set, definitely we are going for supervised. Till this we are on track, and after that now we are having data set. With that data set we are having a label, but whether I should go for classification algorithm or whether I should go for regression algorithm. So among these two you should go with regression algorithm whenever your label is real value. Means it is a continuous value, and whenever you should go for classification whenever you are having the categorical values, means you are having finite set of labels. Take an example. If a salary example. So salary example, is it like that salary will have only the fixed categories like 10 to 20,000 or 20 to 40,000? It is not like that. Someone is having 60,000 something. Some person will have 1,40,000. Some will have 1,40,200. So this is nothing but real value, continuous value. So at that time you should go for regression. In class, when you should go for classification, like take an example, if I would like to implement an algorithm that could predict in future voting, the person will vote to the will cast his vote to which party. So definitely that parties are definitely the finite only. Some are like going to vote BJP, some will be the Congress, or only 4-5 categories are there. So at that time you should go for a classification. So this is the class when you should go for classification and when you should go for regression. These are the reasons whenever you are going to choose the algorithms. In regression, these are the algorithms. The classification, these are the few algorithms. Now we will discuss about a few applications of the linear regression, or we can say just the regression. So like I had discussed, that is if we want to find out the GDP of the country, then at that time to predict what will be the GDP after 3 years, 4 years, then definitely at that time we will use the linear regression. Then if we want to predict or launch any company want to launch any product, at that time it is not like that. They are just assuming something and giving some price to that product. Definitely not. The lot much the big analysis behind before launching any product. They definitely look for at what price this product should be launched. It is also depending on country, in which country they are actually launching this product. Then lot many work is there, and based on that they are going to launch that product with that price. So for that reason also machine learning linear regression is going to be very much useful. The house sprite already I have discussed. Then the as in sports also the machine learning can be used, linear regression can be used. Like suppose if you like to implement an algorithm that could predict after 5 years how many centuries will be scored by Virat Kohli, then definitely this can be done using the linear regression. So these are the few applications of linear regression. That are many applications over there, only few I have listed. So to learn to implement a linear regression, what exactly we need to know? So very first, whenever you want to use any machine learning algorithm, very first task is that you need to have some domain knowledge. Domain knowledge means, suppose I am taking the data set of the whether person is having diabetes or not. So I should know what is the disease diabetes. I should know which are the parameters that are impacting on diabetic. So these things I need to know, like glucose level, then what is the BMI of that person. So some domain knowledge definitely should be there. Second thing that you need to know that you need to the display, or you need to visualize. You should able to visualize your data set. So after visualization of your data set, definitely you could understand which type of algorithm we can use. At least little bit knowledge we definitely get from the visualization. So it is very important to visualize. So let's take an example of linear first algorithm, that is a linear regression. Sorry. So here I have plotted one data. So you can see these data points are look like increasing linearly with the x and y. Your y-axis is nothing but your dependent variable, and x-axis is nothing but your independent variable. So this y is nothing but, suppose your salary, and this is your year of experience. So your salary is dependent on what? Your year of experience. So this is look like that your salary, that is your label, or whichever outcome you want to take it from your algorithm, is dependent on your year of experience, and it is linearly increasing. So at that time definitely we can use linear regression. So whether your data is linear or not, that is also one of the important point. Whether it is linearly increasing or decreasing, both will be okay for linear regression. So what things actually you need to know before implementing the linear regression? You need to know the line equation. You need to know dependent and independent variables, as I had explained. Take example of the house price prediction. We will take this example. So here I have created one small data set about only 10-15 records. In that data set, I'm having two features. One is area and price. Feature means column of your data set, and record means rows of your Excel sheet. So whatever may be your data set you are having, whatever may be columns, these are nothing but your features. Rows are nothing but records or samples, you can say. So I'm having suppose 10-15 samples and two features. Among these two features, price is nothing but my label or outcome, which I would like to predict from my linear regression algorithm. So here, this Excel sheet, whatever may be your data, first you should plot. So whatever may be the red squares, red dots, these are nothing but my data set. This is the data set, the 55 lakhs, 56 lakhs, this, and for which area, respective 2,600, 3,000. So this is plotted. On X you are having area, on Y you are having price. So red is nothing but your data. Now what exactly in linear regression is happening? In linear regression, we try to find out this blue line. The line which is going through each and every data samples. So it is actually not going through each and every sample, but it is very much nearer, closer to it. So definitely there will be not only one line, there will be n number of lines that could go through these data samples. But we would like to find out this line only, because why this is the good line? Because this is called as the best fitted line. And once you get this line, then your linear regression model is ready for prediction. How? If I'm going to give input 3,300 square foot to it, then it is going to predict that it will your house will be sold in 62 lakh. So you will get 62 lakh for your house. So my algorithm is ready and it is predicting now. But how to find out this line? This is very important. So for that reason, you need to know the basic things as I told you. That is the line equation is nothing but the mx plus b or c. B or C is nothing but the intercept, and M is nothing but the slope, and this X is nothing but your independent variable, that is nothing but area in our case, in our application, and Y is nothing but your dependent variable, that is nothing but the price. So in linear regression, we are trying to find out this blue line. That's it. Means we are trying to find out only M and B. Once you get M and B, you provide this X, you will get Y. That is actually the linear regression. So it is not, it is everything is mathematical over there. So here, which line we will say as a best fit line? So because there are n number of lines, if you are going to see, there are lot many lines are there. So which line you will say as it is the best line? The line which is having the low cost error, that line is the best line. Low cost means, what is cost? Error cost meaning is that the difference between actual value and the predicted value. From your blue line for 2,600 area, it is predicting that the house price will be this, but actually it is at red dot. So whatever may be difference here, this difference, then here again this is the difference, here again the difference. Addition of all these differences means errors is nothing but your cost of that line. So which is the best line? The line which is having the lowest cost. That line we try to find out in linear regression, and for that, if you're going to do, then you will have many number of lines, and for each line you need to calculate the cost, and then you will come up to the best line. So instead of that, we use the gradient descent, which takes the jumps based on your first line which you were calculated. Based on that error, it is taking the next jump, and by that way, whichever the line is having the minimum cost, that line is taken as best line. So this is about I discuss about the one variable, that is area I'm taking, but definitely your algorithms will have the more than one feature. Definitely, like take an example of diabetic. If I want to implement an algorithm which predict that whether this person will have diabetes or not, so definitely there will be not only one parameter, that is level of glucose. From level of glucose only you are not going to detect, or if you're going to do using only one variable, then definitely your accuracy will be less, isn't it? Or like same example of a house price. So in only on square foot, like how much area your house is having, only on that point your house is not going to get that much value, because generally your house is price is dependent on more than the only area of house. It is dependent on how many bedrooms your house is having, at which floor your house is there, which location you like. If you are going to take a Pune, then definitely in Pune, if your house is at Kothur or the Koregaon Park, definitely it is having the higher price than the other areas. So meaning is that there will not always be one independent variable. There may be not many different more independent variables. Then at that time, how you are going to use a linear regression, then that is called as a multiple linear regression. So you will have multiple independent variables. Your formula is same of your line equation. You are trying to find out slope and your intercepts only, and then you will give whatever may be input to your algorithm, like suppose here area, bedroom and age, and then your algorithm will find out the price or predict the price. So this is about the linear regression. Any question till now about linear regression? Okay, so now we will take the next algorithm. So though we are having the linear regression with us, then why we are going for another algorithm like polynomial regression? Here, if your data is look like this, whichever shown in slide, if your data is look like this, and if you're as you are aware of the linear regression, then if you're trying to use linear regression algorithm over here, then what is going to happen? Your line will be look like this, best fit line. Then just imagine for 6, your algorithm is linear algorithm is predicting this value, but actual value is this. So you can see how much error is there. So definitely if your data is look like this, and if you're going to use a linear regression at that time, then definitely it is going to give very much less accuracy. So at that time you should go for polynomial regression. Meaning is that if there is the uh, data is look like the curves, then at that time you need to definitely go for the polynomial regression, and that is quadratic equation second degree or third degree or fourth degree, depending on your data set, whichever data set is there. Like suppose my data is look like this, I will go for second order of polynomial. If I am having such a type of data set, I will go for the third order polynomial. Then now we will discuss about or we will see first hands-on for linear regression. Let me share the screen with you first again. Is it visible to everyone?
Yes, ma'am. Yes, ma'am.
Okay, so now we will see first the hands-on on linear regression. So I hope everyone is with the Python. You are having Python with you. And I'm going to implement algorithms on Jupyter. I would like to show you the data set whichever I have generated. This is the small data set that I have generated. Okay, so this is just I have taken one Excel sheet. In that I have labeled first column as area, second as a price. I've taken some area, few of the area and some price. This is nothing but one Excel sheet I have taken. If you want to implement this, I will share afterwards. So how to do it? For that you need to, is it visible? Because I am not able to maximize it. Okay, so you need to import pandas library. whenever you want to implement any machine learning algorithm, then few of the libraries that you need to aware of, that is the first is NumPy, that is numerical for numerical analysis or the calculations, you need to have a NumPy library. Then second, pandas library, that you need to know about pandas for reading your data set and working on your data set. Second, third library that you need to know, that is a matplotlib to plot, or seaborn or matplotlib. You need to visualize your data set. And the fourth library that you need to know, that is the scikit-learn, that is sklearn, to implement the machine learning algorithm. So these are the few algorithms that you need to be aware of. So here I'm importing pandas library. Then I'm going to import the Excel set, means data set. So I'm importing that data set using the read_Excel. If your data set is in CSV, then there is a command read_CSV. You don't need to write this command. You can just give pd dot and tab. So after tab, you will get these commands. Now you want to visualize your data set. So for that, you can like here my data set is very much small, but whenever you do live applications, at that time your data set will be very much used. It may have thousands and lakhs of samples. Then definitely you would like to see first few samples. Then you can use the head, df.head. By this way, you can visualize, or you can see the first 5 samples of your data set. Now I want to plot my data set. To plot, you can have the matplotlib. You need to import matplotlib, pyplot, and why I'm using this PD and this PLT. These are nothing but aliases for your libraries. So PLT dot scatter plot. So I am plotting our data set. On x-axis I am having area. On y-axis I am having price. So this is in this way my data set is look like. Now I would like to implement the linear regression algorithm. So for that, you need to use sklearn library. From that sklearn library, you need to import linear regression class. Why I'm saying class? You can see the classes are given in camel cases. The L and R both are capital. So you need to import the linear regression class from the sklearn library in which model? Linear model. After importing, as you have important class, meaning is that you need to create its object. So I have created one object, and now this object is nothing but my linear regression model, which is going to predict the house of my price. So here this model, I'm going to, now I would like to find out the best fitted line. To find the best fit line, you are going to use function fit. So in machine learning, if you are going to do with Python, then fit function is very much important. So whatever I told you, gradient descent, then it is going to calculate the cost, and whichever line is having the less cost, that is taken as a best fitted line. Everything is done in this fit function only. So you are providing your data set to fit function. Now fit function has calculated that best fit line. Best fit line calculated means it has calculated the slope and intercept. That is y is equal to mx plus c. So it is having m and c. Now we will provide x to it. This is nothing but x, and it will give y to you. Are you getting? So this is actually the linear regression. We will see another example also. That is the salary prediction. Here I am having in salary prediction data set. Let me show you first data set. It is in CSV format. So I am having year of experience and salary. So 2 columns are there. Salary is nothing but label. You can see here. So year of experience is like this, and this is the salary. So from this, I would like to implement the linear regression algorithm. So as I had discussed, you need to import pandas library. Then you are going to read your data set. How to read now? This is in CSV format. So read_CSV. Then check it out. What are the different columns and what are the values? For that, you can check it out the first few samples using the head function. Now you are going to plot your library. Sorry, your data set using the matplotlib library. So your data set is look like this. Now you want to find out what you want to find out. You want to find out best fitted line. So for that reason, you are going to import linear regression function. This is the linear regression function. You are going to import from sklearn library. Then you are going to create the object for your linear regression class, and this reg underscore model. This is nothing but your machine learning model for linear regression for this salary application. Now to this you will provide your data set. From that data set it will find out the best fitted line, means it will find out M and C. And after that, whenever you are going to give X, it will predict your Y. Y is nothing but your salary. So this way you are going to implement your algorithms. But whichever algorithm you have implemented, definitely you need to know that whether this algorithm is good or not, whether it is giving accurate results or not. So definitely you would like to check accuracy of your model, whichever you have created. So for that reason, what is done, whichever your data set, this data set is going to be divided or part of data set. Suppose you are having thousands of records. Among thousands of records, you will give 800 records for training, means to fit function you will provide only 800 of data, and to test it, like here I had given 9 means 9 years of experience, and it is giving the salary. So 200 data set, 200 records I will keep for testing, and I will give the 200 records to test at the time of your model. Then it will find out among 200 the samples, how many samples it has predicted correctly, and based on that your accuracy of model is find out. So how it is done? This is done using the train and test function. So here you are going to import train and test split function from the sklearn. Here I am providing the year of experience and salary, whatever our data. In that I am providing 0.3 to test, meaning is that 0.7 means 70% of records. So if I am having 1000 records, then 700 records I am giving for training. So here in X train and Y train, you will have your, in X train you will have what? Year of experience. 700 records will be in X train. In X test, what will be there? Remaining 200 year of experience records will be there. In Y train, respective outcome of X train, like, let me show you. Okay, so if I am giving 70%, so this much records will be suppose given to your training. So this is nothing but my X train, and this is nothing but my Y train, and these are nothing but my X test from this 6, and these are nothing but my Y test. Are you getting? But it is not done manually. This is not given by us that this record you should take. This is taken randomly. Randomly it will choose among 1000 records. Suppose I am having 1000 record and I am giving 0.3 for test. You can declare here train also, train size also you can give. So train size will be 0.7. Here I have given test size. So 700 records will be taken for training and 300 record will be taken for testing. So this is linear regression model. I am going to one of the object of linear regression model I'm going to create. And to this model, I'm not going to give complete data set now. To train this, I will give only how many data sets? 700 as example. Means X train and Y train I will give. After that, in this fit function, it will find out best fitted line. Now your model is ready to do prediction. To that, but we want to find out the accuracy. So what we are going to do? To this model, we will use core function, and in that we will give X test and Y test. Meaning is that for this X test, what your model has predicted is going to be checked with actual values. So Y test is nothing but actual value, and this model is going to predict Y predict. So how many Y predicted values are same as Y test, means how many samples have predicted correctly. Based on that, your accuracy of your algorithm has been given. Is there any question till now?
If participants would like to ask any question, please raise your hand so we can unmute you.
So, okay. So this is about the linear regression. Same way you can go with the other algorithms also, like polynomial and the other algorithms. So if I'm having that, then I can show you. Just give a minute. Yeah, I'm having for polynomial, so I'm having the code that I can show you. So again, I'm taking salary and experience with for creating a model. But when I have visualized, then I can see the data is look like this. If you're going to apply linear regression model to it, then you can see your score. Score means accuracy is only 0.16. Only 0.16 means it is very the bad algorithm which we have implemented, because its accuracy means only 16% of time it will give correct answer. Other time it may give wrong answer. So for such a type of data, definitely we should have taken polynomial the polynomial regression we need to take. So for that you need to say that how much degree of polynomial you want to take. So that degree you need to give as degree is equal to 2. You need to import polynomial features, and for degree 2, this nothing but meaning is that the degree 2 equation you need to convert your x, means whatever may be your x values features, that you need to convert in the form of polynomial. So that is done by fit transform. So now this x is going to be in the form of degree 2 of your polynomial, and then you are going to import linear regression class, and you are going to create a model or object for linear regression. And to relate this linear regression, you will not give this x, you will give whatever may be transformed, means your x actual value are going to be transformed into degree of 2, and that value is given for fit function, and then it will find out this curve, red line. So this is nothing but your base fitted line, which is find out by this fit function. If you are giving only this x to your linear regression, then how it is going to be, look like straight line. But you have done you have transformed your x values, these are the x value experience, this is you have transformed in the form of degree 2. That's why your fitted line comes like this. And now if you are going to see this score, then you can see that the score is the more than 80%. If you are going to find out, yeah, 92%. So this is the way you should use polynomial regression. So you need to first plot it, then from that plot find out how much degree of polynomial you want. Then that degree, in that degree you need to transform your x means that columns features on which you want to predict the values, predict the outcomes, that all columns you will provide for transformation, and after that they transformed your new values that will going to be given to fit function. Ultimately you are using linear regression only, but for that you are not giving plain data, you are giving transformed data. In which form it is transformed? It is transformed in 2 degree of equation. So this is nothing but how can we find degree value? Yes, so for that we need to plot the values. So whenever you are seeing that one curve, then definitely it is 2 degree. If you are having the more curves, then based on that curves you are going to increase your degree. Like suppose my data is having 2 curves, then definitely I will go for the 3 degree of polynomial. So here what problem comes in polynomial regression, that of overfitting. If you are going to take too much of degree like 9 or 8, at that time it will be overfitting, and then it is going to result for the less testing accuracy. So for that reason, first you need to plot, then based on curves you need to give the degree of your polynomial, then check it out whether at which point it is giving moderate result. So it may possible for 9 degree it is giving 95 of accuracy, your trading accuracy, but in 6 it is giving 86. But in testing 6 is having good accuracy and 9 may have lower. So at that time instead of using 9 degree you can use 6 degree. So are we getting? So it is about which value it is giving better testing accuracy. Testing accuracy and training accuracy, these are the 2 different things. So testing accuracy means when you are giving new data, and at that time how your algorithm is behave. Based on that you are going to find out degree of your algorithm, and actually it is based on the shape in which way your data is visualized. On that you can decide. So this is about the first part of the discussion. In second part, just give me a minute. Okay, so sorry for interruption. I just took water. Okay, so now till now we have discussed about the regression. There are lot many different points that also you need to know, like the L1 regression, L2 regression. Lot many different things are there. The overfitting and underfitting. But now we will move towards the second category in supervised learning, that is the classification. As I think I had already explained, when you should go for classification, when you are having the finite values of labels. So means if your labels are of only 3 or 4 types or only 2 types, then at that time you should go for classification. There are two type of classification. One is binary classification and another is multiple classification. Binary means your labels are only two. Only two labels are there. At that time you should go for binary classification. And the multiple classification means you are having more than two classes of your outcome. So here few algorithms I have enlisted here on this slide. That is logistic regression. Though it name look like regression, but it is used for classification. Then support vector machines, decision tree, random forest, and actually many other also. But we will discuss only this a few of the algorithms. So now take an example. I am having data set of the people who have opted for, means I have data set about the insurance, means insurance company data set I am having. In that I am having two important features: age of person, and second, whether he has opted or he or she has opted for insurance, yes or no. Means this is binary regression in short. So from this data set, I would like to implement the machine learning algorithm to which if I'm going to provide age, it should say, tell me that, or it should predict that whether that person will opt for insurance or not. So this is the question in our hand now. So if I'm going to visualize this data set, this look like this. Means the people, this at one, whatever may be data, this is nothing but, just a second. So this is nothing but the data. These are the people who have opted for insurance, that is value is 1. These are the people who have not opted for insurance, their value is 0. So this is the data set. If you are going to visualize, this will look like this. Now I would like to implement the machine learning model. As now we are aware of the linear regression, then what we can do, we can just find the best fitted line, isn't it? So I will try to find the best fitted line, and then I will see whether this linear regression is giving good result or not. Then this line will be look like, suppose this is the way this line is. I can see this line this way here. So this in this line, if I'm going to look for 40 age, then this line will predict that for 40 age, this is prediction, this is below 0.5, so it is saying no, but actual value is yes. Are you getting? So here your accuracy is going to be very much less. So below 42 age, people have not taken the insurance, and above 40 people have taken the insurance. This is the conclusion from our best fitted line if you are going to use the linear regression. But if there is outlier, then this line is going to be deviate, and definitely your answers will be in the form of 02, 03, 04, 05, 07 or 08. Like suppose take an example here for 45 age people, then my answer will be here 0.4. But here what you want answers in 1 and 0 only. Either it should be 0, either it should be 1. So for such a type of applications, definitely Suppose this was the outlier. Because of this outlier, these three values, though they opted for insurance, but they have predicted they are as no, because if you are going to take this as a best fitted line, so here it is giving below 5. So we will see that he has or she has not opted. So this is again no, this is again no. Means wrong prediction, means very much less accuracy is there if you are going to use linear regression over here, and it will have the values different than 0 and 1. Our aim is value should be 0 and 1. So for that reason, we are trying to find out such a line. We want to find out such a line, and this line can be found out using the logistic regression and by using the sigmoid function. So in linear regression, we have find out the best fitted line using the line equation. Here we will use the sigmoid function. What is the main aim of sigmoid function? Keep your values in 1 and 0. It will not have a value more than 1 and less than 0. So it will keep in between your values between range 0 and 1. So here in left hand side you are having equation for linear regression, and for right hand side you are having equation for your logistic regression. So you can see that this is a sigmoid function, 1 upon 1 plus e raised to your z. Z is nothing but equation of your line. So this is nothing but the equation of line. So this way logistic regression is implemented using the sigmoid function. Now if there is a logistic regression which can classify your data into two parts, like here you can see our logistic regression can definitely divide this whatever may be data in this way it can classify. So whatever may be data this side, meaning is that they are not opted for insurance. Data in right hand side, these are opted for insurance. So here if you are having such a logistic regression algorithm to classify your data, then why there is need of another algorithm, that is support vector machine? We will see the answer for this question. If your data is look like this, then are you able to classify this data using sigmoid? We will definitely not classify, because there are two classes. These are actually visible to us as a human. We can say that this is the blue ones and green ones. Green ones are in one class and blue ones are in one class. But definitely not using linear regression and not also logistic regression algorithm is also not able to classify this. How it will classify this? It is not able to classify because this is not your linear data. So at that time, you require such type of algorithm that are nothing but SVM, support vector machine. So what is done in support vector machine? And now you can see this data is 2D, that is X and Y, two axis in that our data is presented. In SVM, there are the concept of kernels, and what they do, they are going to convert your data from lower dimension to higher dimension. Means if this is your 2D data, it will be converted into 3D data, and then it is going to be classified using the hyperplanes. So that is done in your SVM. You can see here. This was the two-dimensional data. Using the SVM kernels, it is represented in the form of 3D data. Here you can see X, Z, and Y is nothing but two parallel to your screen. So we are not able to see that, but yes, this is represented in the form of 3D, means dimension has been changed. And now you can see using this orange line, you can definitely classify this two data. This is called as your hyperplanes. So this is the concept, and this is the reason why we are actually going towards SVM algorithm. Now we will discuss SVM algorithm, how it works. Like take an example here. I am having this data. I want to classify this data. For classification, I can classify this data using line B. Then I can classify data using another line, which I have not. This is suppose D line. Then this is another line. Suppose this is E line. Means lot many lines I can draw, and I can classify this two classes. But among these lines, which line should be taken? That is the question in SVM. So here I have taken for visualization, this is the Aries data set that are plotted over here. So 3 lines are there, blue, orange, and the black. Among these 3 lines, which is the better line, or which we should take as the classifier or boundary line. So this is done in SVM. How it is done? The line which is here, to choose the line, we are first finding out the support vector. So now what is the meaning of support vector? The support vector is nothing but the line which are going through the data samples which are at the boundary. So this line is going through this data set at the boundary. This is going through the blue one. So these are nothing but these two are called as support vector. Here also in this same data set, you can find out another support vector. So you can find out different pairs of support vector. In that, whichever support vector is having higher margin, that support vector is taken as the best support vector, and from that line, whichever you are going that plane, that is called as your SVM plane. So it is called as your SVM plane. Now, why we are taking the higher margin? We are taking higher margin because it will give good accuracy. If you are going to take a lower accuracy, then what is going to happen? If here is the one data point, suppose this is the one data point. So if you are going to take a lower, it is going to say that this is the circle. It is going to predict circle, but actually this is the square. If you are going to see this, if this is the line, this support vector, if you are going to take, then this is going to predict it as square, and that is a correct prediction. So to improve the accuracy, we are taking the support vectors which are having the higher margin, and then that line going through that, it is nothing but your hyperplane. So if it is 2D, definitely it is a simple line. If it is more than 2D, it is nothing but your plane. So that plane you are going to take to classify your data. So in 3D or more, it is going to be look like this. So this is nothing but a plane which we have find out using the SVM algorithm. So here in SVM, we are trying to find out the support vectors. Now, to finding out the support vector, there are lot many questions. The very first question is how many. You can see the beauty of SVM is that in previous algorithms, linear regression, logistic regression, if you have given attention, all data points, all samples of your data set have taken in consideration while calculating the best fitted line. But in SVM, if you have given the attention, then you can see that only few points are taken into consideration to find out the support vectors and hyperplane. Meaning is that it is going to be very much lightweighted, because it is going to be used very few samples for calculating your plane. Now question is that how many boundary points it should consider, and how your, right now I have shown only straight line, but it may have curve depending on your data. So it should, how many points it should consider, and the how curve of your plane should be. That is done using two important points, that is called as hypertuning points of SVM, that is called as gamma and regularization. Gamma is nothing but how many data samples on your boundary that should be considered. If you are considering less number of data points, meaning you are having higher gamma. So if you are taking less numbers, then definitely your accuracy of your line is going to be higher one. Then regularization. If you are going to take too much of this is going to be, it is trying to take each and every trying to classify each and every point, means it is taking very complex shape of your plane. Then at that time it is called as high regularization, and which converts into the overfitting problem is happened because of high regularization. So now, and in low regularization, your model will have the low accuracy, so it should be little bit moderate. And these two parameters, regularization and the gamma, these two parameters you can tune while whenever you are implementing SVM algorithms. You should tune it, and then you should come up to the some point for gamma and the regularization. Any question till now? Okay. So next, as we have discussed about SVM, though we are having SVM algorithm, till there is need of another algorithm, that is the decision tree, as it is going to be execute very much similar to the human brain. It works like a human brain. If you have any question, you can unmute and you can ask me, okay? Or you can just give in the chat box. Sorry. So here, if you are going to see your data is going to be look like this. So at that time in machine learning, what actually we are finding out? We are finding out base fit line. Base fit line is actually we are finding out the boundary line. Boundary line which can classify the different points. Means similar points should be at one place and different points should be distinct from the similar points. Like take example here. So if here I would definitely like to find out such a boundary lines. Means this green point should be segregated from the red one. So such a type of boundary lines we are trying to find out. So why we are going to use decision tree algorithm? So decision tree algorithm is very much similar to human brain. Like you have opted for this FDP. So is it like that there was the registration link and you are directly just register over there? Definitely not. You must have given thought how many days of. Yes, definitely. I will discuss about kernels. So here in SVM, we were having the mainly 3 type of kernels. So in that RBF kernel is very much important because RBF kernel can able to take any type of shape. So if you are having complex shape of your data, means like here your data is very much easier, like whichever data is shown. Yeah, this data is very much easier. But if you are having very much complex and non-linear data, then at that time any type of shape of that data can be categorized, can be classified using the RBF kernel. So at that time we need to use RBF kernel, and how we should use that kernels, how you are going to change that kernels, that I will show at the time of hands-ons. So in Python we are having facility to change the kernel. You can tune your parameters gamma and the regulation. Same way you can change the kernels whenever you are executing your algorithms. So best kernel till now, that is nothing but the RBX kernel, which is the best for whichever maybe type of your data, whichever the complex data you are having non-linear, that can be classified using the RBF kernel. So here okay sir. So here in decision tree algorithm, if you are going to yeah, I had given example that you have opted this FDP by thinking some questions. Definitely there might be in your head that whether it is 5 days, then more than 1 week, or it is a 1 week. If it is 1 week, then definitely certification of this FDP is going to be useful for me, for my profile. Then second question could be the whether whatever may be the contents of this FDP, these are going to make some value addition in my knowledge. Then third thing, whether what all may be the resource person, they are going to discuss about the theoretical concept or mathematical concept or the implementation view. So point is that there are set of questions, and based on the answers of that question, you come up to your conclusion. That is, yes, I would like to join this FDP, or I don't want to join this FDP. So same way in data also, if you are going to take some set of questions, if you are going to find out the tree-like structure, then you will able to reach to your output. So that is done using the decision tree. So whichever may be your data set, on that data set you will have suppose 10-15 features. So very first you will take one of the feature as a root. From that feature, whatever may be the values in that column, based on that columns you are going to find out the intermediate nodes. Then you are going to find out the next nodes. Likewise, tree structure you are going to find out, and you will come to conclusion. That is the working of decision tree. We will see here with an example. I have taken one data set. Let me explain that data set. This data set is about to predict if I'm going to join this company, so and so company, whether I will get more than $1,000 salary. To predict that means answer will be either yes or no. Means you might get more than 1,000K salary, or you will not get that salary. In that data set, how many features are there? There is the first feature, that is company name. Then second feature, post of employee, and third feature is the qualification of that employee. So in my Excel sheet, I am having 4 features. First feature, the employee qualification, then employee post, and in which company employee is working. And the fourth feature, that is nothing but whether he has getting more than 1,000 salary. So this is the data set I am having. So from this data set, I would like to generate the decision tree algorithm, which will able to give me, predict me if I am going to apply, suppose ABC Pharma, and I am having suppose this of the business manager post, and I am having bachelor's degree, then whether I will get more than 1,000K salary or not. So it will say no, you will not have, based on this decision tree. So this algorithm I would like to implement. So in this algorithm, trees are implemented. Now here you can see among these 4 features, first feature they have taken as a company as a root node. Then for company, how many values in Excel sheet? So in Excel sheet, in company column, you are having these 3 values. So next node will be these 3 nodes: Google, Facebook, ABC Pharma. After that, for Google, in Google company, what are different posts are there? Then ABC Pharma, what are the posts? So there will be answers for that. And for respective post, what is the degree and what is your output, exact output? That is, yes, you are, no, you are not getting more than 1,000 salary. Yes, that person is getting 1,000 salary. So such a way your tree has been created, and whenever you will provide input to it, it will traverse that tree and it will give your answer. So question is that here now, among these 3 features, that is company name, then the post and qualification, among these 3, why this decision tree has taken company as a root node? This is the question. Because if you are going to take some another root node, then your answer is going to be, accuracy is going to be less, or it is going to be complex tree. So question is that which feature, in which order we should select the feature. This is the important question at the time of decision tree. Then how to find out the root node, which feature should be the root node? That is done on basic 2 points or 2 important concepts, that is the Gini impurity and the entropy, or you can say entropy, you can say in different words, the information gain. The feature which is having higher information gain, that feature is taken as a root node for your decision tree. So here if you are going to take a company, entropy means it is nothing but the randomness in your feature. So if you are going to take company root, for this feature, if you are going to find out the entropy, then you can see that for Facebook, all the employees having the S answer, means they are getting more than 1,000 salary. So there is the randomness is very 0, because all is having S answer. Here your 1 is having the yes answer, 2 or 3 are having no answer. Then here in degree you are having the all 4 answers are different, means this is, if they are in the Google, if they are having the bachelor, they are not getting the answers, means randomness is more. So it is going to check the randomness. So this company is having less randomness, meaning is that which is having higher information gain than this feature. Degree is having low information gain. Because of that, you are going to select the company as the root node. So this can be done using Gini impurity also, but this is having many different calculations. So this way, the decision tree is generated. Very first, it will find out the root node based on whichever maybe concept you are talking. If you are going to take high information gain, then it is going to check which node is having the which feature is having higher information gain, then that is going to be take as your root node. Then based on that, what are the values for that feature, that will be your intermediate nodes. Then again this process is going to be continue iteratively until you will come up to the your outcome feature, and this way your decision tree has been created. And using this algorithm, your accuracy is very much higher, but still there is again a scope. Like if you are going to take complete 1000 records, if you are going to give for decision tree, so for all 1000 records, one of the feature will have higher information gain. One of the feature will have higher information gain. But if you are going to divide your 1000 records into 5 bunch of 200 samples each, then if you are going to give this 200 bunch, and if you are going to find out information gain for feature, then it may possible that all these 5 bunch you are having different features which is having higher information gain. Are you getting my point, what I'm trying to tell you? If we are going to provide all 1000 records to decision tree, then it will find out for all 1000 records one of the feature which is having higher gain. But if we are going to divide your data set into suppose 5 bunches, then one of the bunch another feature will have higher gain, then in second bunch you will have another feature as a higher information gain. Then meaning is that if you are going to predict using decision tree, using only one of the feature will be root node and your answer will be predicted. But if you are going to use this concept that divide the complete data set for and apply your decision tree algorithms, then each and every decision tree algorithm may have different conclusions. Then whichever conclusion is in a majority, that conclusion is taken as your final answer. Means final outcome will be taken using the majority is given by your decision trees, and that is called as ensemble learning, and that algorithm is nothing but the random forest. So random forest is a classifier by which we can improve the accuracy of your decision tree algorithms. And there are two types, that is a bagging and boosting. Based on that, in the boosting, what we are going to do, whatever may be the wrongly predicted samples, that can be given to the next algorithm, and by that way we will try to improve the things. And in bagging, this is the concept that we will divide our data set and then we will take the voting, whichever may be maximum output, that we will take as our output or final output. So this is about the classification algorithm. And the next the classification algorithm, that is nothing but the k-nearest neighbor, which is I think everyone is aware, as this is there in our bachelor's syllabus, that is k-nearest neighbor, which is based on the distance of, and it is classify into different groups of your data based on the Euclidean distance it is taking, and based on that it is going to find out and then whenever we are giving new input, it will predict that this new input will be whether from this category A or category B based on the distance from both of the centers of your categories you have decided. So this is about the all algorithms. So is there any question? Now we will see the demonstration here. Give me a minute. Okay, is it visible to you?
Yes, ma'am.
Okay, so here now we will see the classification algorithms. So whichever algorithm I had explained at the time of logistic regression, that was the about insurance, whether the person will opt for insurance or not, that I would like to, we would like to create some algorithm that will predict. So for that reason, we have taken the Excel sheet, that is nothing but data set. So we have imported the pandas library and matplotlib library for plotting the things. So here the insurance first line, that is import pandas as PD, meaning is that we are importing pandas library as this variable name PD. So after that, pd.read excel, this is the command to read your data set. So insurance.xls file, this is nothing but my data set. Now what are the different columns is there in that data set that we can see using the df.columns, that is also one command. Otherwise you can directly see df.head means some samples you can see. So here you are having two columns, age and insurance status. 0 means the person have not opted for insurance, 1 means person has opted for insurance. So this is the data set. Now this data set is plotted this way. Now I would like to create the logistic regression machine learning model for prediction. So for that reason, whatever may be data set, I would like to give some data set to train and few data samples I will keep for testing. So that you can do using the train test split, whichever I had already explained. That is, you need to import train test split from the sklearn library and model selection. From that you need to import this. Then you need to give here 0.8 means 80% of data is given for training and 20% of data is kept for testing. So here df age is given for training and testing. So x10 is look like this. These are the features in x10 and these are the features in xtest, and these are in ytrain. You can see that also. You can just give a command y_test, so it will give what values exactly there in ytest. Now I would like to implement logistic regression. So I have imported logistic regression of class from the sklearn library. Then if you are taking class, then meaning is that you need to create object for it. So log model is nothing but the object, or you can say this is your logistic regression model. This is nothing but your machine learning program. Now you have created that, but you need to fit that. Fit means you want to find out the best fitted line. To find the best fitted line, you have given x10 and ytrain over here, and this way you have find out the best fitted line, and now your model is ready for doing the prediction. So here I am given the prediction age is given. It is going to predict that yes, person is going to opt for insurance or person is not going to be opt. So you can do prediction using the predict function. If you want to find out the accuracy of your model, you can find out using the score function. To that you need to provide xstat and ytest. So you will give xstat to score, it will predict your y, that will be y prediction, and ytest is nothing but your y actual. So difference between y actual and y prediction, it is find out your the score means accuracy. So this is about the logistic regression. And if you want to see the performance of your algorithm, then you can find out using the how many samples were true and these are predicted correctly, means true positive, then false positive, then the false negative and false positive. That you can see using the confusion matrix. To plot this or to calculate the confusion matrix, you need to import confusion matrix from sklearn matrices, and then you need to provide your ytest and ypredict to it. Then it is going to give your confusion matrix parameters, that is the precision recall. This will going to be provided with this confusion matrix. So this is about the logistic regression. Is there any question? Okay, so next algorithm. This is logistic regression. I have shown only for one variable. So if you are having multiple variables, then how you are going to do that? So as process is same, you are going to read your data set using the pandas, read Excel or CSV file. So this is the data set for diabetes, that is this person. 1 means person is having diabetes, 0 means person is not having diabetes. And these are the features, like what is the glucose level, what is the age of person, then what is the BMI, what is the insulin level, then what is the blood pressure of that person. So these are the features, and outcome is whether person is having will have diabetes or not. So we want to predict that. So to create this machine learning model, whatever may be the features I have taken into the X. So in X, I have taken these features. How many features? This one up to H. And outcome is nothing but my label. This I have taken into Y. As we are learning supervised algorithms, and this is a classification. So supervised learning algorithm, this outcome is nothing but the label of your program. Then I'm going to use the train test split. The 25% data I will give samples I will give to test, and 75% data I will give to train. So here I will, as the same process that I'm going to import logistic regression class, then I will give the X train and Y train to fit, and then I will find out the score. Now here, question is that I have given all features, but it is not like that in data set, whichever you are getting data set from the hospitals or somewhere else. In like suppose I would like to create the model for prediction of on the shoppings. So from mall I have taken data. So it is not like that which are the features, all features are very much important for my outcome. Definitely not. Like in mall data, it may possible there is a name of person. Like suppose in this diabetics data, there is a name of person. Do you think this name of person is having any impact on your outcome? Is it like that the so and so name of person they are having diabetes? No. So name of person is definitely not going to have any impact in that. Address of person definitely will not have outcome into that. So this is whatever may be your data set. This is the clean data set. This is ready for execution. That's why we can directly execute our algorithms. But in real time, lot many data set having lot many features, and among that features, few features are not having impact on outcome. And at that time, feature selection is very important. In machine learning algorithm, instead of implementing these algorithms, what is important? Data preparation. Data preparation is very much important. I think 75% or more time data scientists are investing on the data preparation, and this is given on internet also, and not many surveys. They are given that more than 80% of time the scientists have invested in data preparation. So what is done in data preparation? Missing values are handled, noise or whatever may be noise that is removed from your data set. Missing values means if one of the value, this 8 was not there, this is empty cell, then this should be filled by somewhere, some value. So that is nothing but the handling missing values, and that is done using the, I hope everyone is aware over here, that is done using the measure of central tendency, that is mean mode median, that is used to handle your missing values. Then second thing, handling outliers, it is very important. So you need to first visualize your data, or you can just plot box plot, or you can use the IQR, and from that you can find out what are the outliers. Then handling outliers is very important. Third thing important is that you are from among the features, which features you need to take for the your analysis, that is very important, and that is nothing but feature engineering, and that is done using the PCA, principal component analysis. By that way you can reduce your dimensions, or you can use directly correlation. So we will see here how correlation has find out. Like suppose I am having this data set with this many features. So among these features I would like to take only few features which is having high impact on outcome. I don't want to take all these features. Why I don't want? Because all features are not actually impacting. Then how I will find out that? Here I will take a correlation function, CORR. I will apply that function on my data set, and then I will find out the correlation with my outcome. So correlation with outcome for all my data, I will print like that. So first feature is having 0.2 correlation on outcome. Glucose is having 0.46. So from these values you can say that this glucose is having higher impact on your outcome. What is outcome? Whether person is having diabetes or not. So by how you are going to find out? You need to first find the correlation function on your data set. Then after that you need to find out this correlation with which your outcome. And then you are going to find in this variable called target, you will have the correlation of each feature with outcome. So this glucose is having 0.46 correlation, means it is correlated 0.46, means 46% correlation is with outcome. So it is having higher correlation, meaning is that there is some relation between glucose and outcome, and which is the higher relation, meaning is that it might be that if your glucose is increasing, you are having higher chances of diabetes. If your glucose is decreasing, you don't have a chances about the diabetes. Means whether it is positive correlation or negative correlation. Like take a house prediction, your area is correlated with price. So if you are going to increase the area, like suppose my house is 2000 square foot, then I will get 50 lakhs. If my house is 3000 square foot, I will get price as a 70 lakhs. Are you getting? So these are positively correlated features. And then if the years of or age of your house, if my house is 10 years old, then definitely my price will be greater than the if my house is 20 years old. So my how the age of my house is correlated with price, but negatively. So both type, positive or negative, both type of correlations are very much important. Meaning is that that features are impacting on your output. So that features you should take for prediction. So here I have chosen from all these features, I have chose feature which are having more than 0.23 correlation. So these are the only three features which I have taken, that is glucose, BMI, age. These I have taken for my analysis. And then if you are going to see, your accuracy is going to be definitely increased. So this way you are going to find out which features I should take for the data analysis or further your model building, which model you want to build. Now I would like to explain the next algorithm. Here we are having SVM. So for SVM, I'm having the Q3 implementation is done. So here the Aries data set is already there with sklearn. You just need to load it. Then what are the features are there? That is nothing but the sepal length, width, and the petal width. And the target is nothing but we are classifying whether it is the setosa, versicolor or virginica type of the flower is. So this is the application where we are going to classify the flowers based on your sepal and petal width and length. Based on that, you are going to classify this into these three categories. So for that, we are going to use over the SVM algorithm. So we are plotted this way. It is look like this. So petal length and width. So very first you need to plot your data set, and after that you are going to find out that which algorithm we are going to use. So here if you want to use SVM algorithm, you need to import the SVC classifier. So you need to import SVC classifier from sklearn, and after that you need to train this algorithm using again fit function, which is going to find out your support vectors and hyperplane based on your data. So which is your data? Data is nothing but X train and Y train. So whatever may be your data set consisting of mainly four features: sepal length, width, petal length, and petal width. This is given for training, and outcome is nothing but its class. Class is what? Three types of class: setosa, versicolor, and the last one is virginica. So these are the three targets. So we want to classify. This is a multi-class classification. So here if you are going to find out score, it is 0.993. Now you can hypertune your SVM model. How you can hypertune? I had explained regularization. Regularization means how much complex shape you would like to take. So this is nothing but SVC. In that you can give C is equal to. So C is equal to 1 means it is the lower simplest, means it is not going to take the complete nature of your data set. It will take a simpler nature of your data set, meaning is that few points may be classified wrongly, but if you are going to take a 10, then it is going to take, means it is the overfitted model. this way you can hyper-tune your model using the C parameter. And whenever you want to take how many sample points from the boundary that you should take, that you can use using the gamma. So gamma is nothing but how many points that you need to be taken to calculate your support vector. So here I have provided 10 and here I am providing 100. So you can see if I are providing maximum more points, then I am getting less accuracy. Are you getting? So this way you can hyper-tune your parameters. And someone has asked about the kernels. So there are, you can use linear kernel, or you can use the, here lot many types of kernels are there. If you are going to shift tab, you will get that. So in that you can use linear kernel or RBF kernel. Based on that, you will get your accuracy of your model. So I think I should stop for here. If you are having any questions, I would like to answer the question. And if you want to contact me, then this is my email ID and contact number. You can contact me at any time. You can just drop an email or WhatsApp me. I will be happy to discuss with you for the some applications or the whatever maybe projects you are working on ML. So thank you, Ram sir, for providing me opportunity to discuss with the participants. And the participants, if you have any question, you can unmute and ask me. I will happy to answer. That's it from my side, Ram sir.
Thank you, ma'am. Thank you. Participants, if you have any question, please raise your hand. Okay. Thank you, ma'am. It was very effective and informative session for all the participants. You have discussed about artificial intelligence, machine learning, regression, type of regression, and their applications. All content were very useful for the all participants. I am sure that it will help to the participants who are new in this field, because you have started from the very basics. Thank you, ma'am. Thank you.
Thank you, sir. Thank you.
Over to you, Ram sir.
Thank you very much, ma'am, for joining with us in our FDP. And dear participants, today's session is over. Today, we have learned the many things like machine learning, artificial intelligence again, and we will conclude the session today. We will meet tomorrow at 10 a.m. morning. Thank you all.
Thank you, sir. Thank you, participants, for patience listening. Thank you. It was nice interacting with you. Thank you, Ram sir, for giving me opportunity.
Thank you, ma'am.
Take care. Bye.
Okay.